Okay, this is lesson 4.3, rational exponents. A rational means fraction, and so in the case of rational exponents, we're talking about exponents that are fractions. So a rational or a fractional exponent equals a radical, and radicals are something we looked at last unit. What that means is that you can take those fractional exponents and rewrite them as radicals. So in the case of a to the exponent 1 over n, that's the same as saying the nth root of a. The bases stay the same, they're both a. The exponent on the top 1 becomes the exponent on a, and n, the bottom or the denominator of the fraction, becomes the root. So it's the nth root of a. Some scenarios here, we have to have n being a natural number. So you can only have natural number roots, so numbers like, first root would be just a number, but like 2, 3, 4, 5, 6, 7, 8, 9, 10, no negatives. If n is an even number, so you're taking an even root, that a has to be greater than or equal to 0 in order for there to be a real answer. And basically that boils down to, you have to remember taking the square root of a negative number, you couldn't do it. That's kind of describing this scenario here. You also can't take the fourth root of a negative number, or the sixth root of a negative number. And it's for the same reason that you can't take the square root of a negative number. You can't get a real answer because there aren't two of the same number that could multiply together to give you a negative number. Two negatives multiplied together gives you positive, two positives gives you a positive. There's no way for that number to be the same and give you a negative. But if there's an odd root, like a third root, you can multiply 3 of the same number to get a negative or a positive. So you can take the odd root of any real number. So this lesson is about taking advantage of radicals and fractional exponents to simplify and solve some expressions. So in the case of 3 to the exponent 1 over 2, if we wanted to rewrite this as a radical, we would say 3 is the base, the exponent is the numerator 1, which I'm not going to write because it's an imaginary 1, and the 2 becomes the root. So this becomes the square root of 3. And we can generalize this a little bit further. If there's a numerator that's not 1, similar scenario, the numerator that's not 1, 2, becomes the exponent on the base 3. So this becomes 3 to the exponent 2. And the denominator becomes the root. So this becomes the third root of 3 squared. Now, the question is, which do you do first? Do you square the number and then take the root, or do you take the root and then square the answer? Well, you can actually do it either way. So another way to rewrite this would be the third root of 3 and the answer squared. It's the same thing, and you'll get the same answer. So either third root of 3 squared or 3 squared third root. Or, sorry, I guess you could even say the third root of 3 squared. So let's try a couple examples here. I'll leave the rules up there. We're going to turn these 4 expressions into radical form. So we've got 2 to the exponent 1/3. Well, the exponent, or the numerator, is 1. So the exponent on 2 becomes 1, and the denominator is 3, so it becomes the third root of 3. And that's written in radical form. It's not evaluated because we don't have a final answer. This is the radical form, and that's what the instructions say, write in radical form. The next one, similarly, again, the denominator is 3, so it's going to be the third root. The base is 6, and the exponent, or the numerator, of the fraction is 4. So this becomes 6 to the exponent 4, third rooted. Again, not a final answer because, well, we haven't evaluated. This is just written in radical form. If you wanted to evaluate, you could take 6, raise it to the exponent 4, and then take the third root. Or you could take the third root of 6 and raise the answer to the exponent 4. Either way would be fine. C is a little tricky here because we have a negative exponent. So let's use our negative exponent rules and rewrite this. This would become 1 over 9 to the exponent 1 over 5. Remember, a negative exponent, bring it to the bottom of the fraction, or take the reciprocal and make the exponent positive. And now, on the bottom, we have a denominator in our fraction of 5, so that becomes the fifth root of 9, and the exponent would be 1, but we don't need to write it. So this becomes 1 over the 5th root of 9. Last example, this time we have a coefficient as well as a variable. How does this work? Well, same way as all the other ones. Just the base is now 3 to the exponent x. So the exponent on 3 to the exponent x would become 1, and the root would become 2. So we get the square root, or second root, of 3 to the exponent x. Now, if the numerator was something other than 1, we'd have to put that in brackets and raise it to that exponent, or put the whole thing in brackets and raise it to that exponent. But since it's 1 in the numerator, we don't have to write that exponent. All right. Example 2, similar. We're going to simplify and express our answers with positive exponents. Simplify, really, I'm going to change that instruction actually. We're going to go with evaluate. We can evaluate and get a final answer. It would say simplify if we had some variables involved, but we don't. We just have numbers for all 4 of these examples, so let's evaluate. We're going to take here the exponent, or numerator is 1, the denominator is 4, so that's our root. So we're going to take the 4th root of 16. How do you take the 4th root of 16? Well, without your calculator, you ask yourself, what number could I multiply by itself 4 times to get 16? And you know 4 times 4 is 16, and 2 times 2 is 4. So is 2 times 2 times 2 times 2 16? The answer is yes. So the answer is 2. B, no fraction as our exponent this time. It's a decimal. But we know we can rewrite all decimals as a fraction. This is 5 tenths. 5 tenths is the same as 1/2. So our fraction is 1/2, which means we're just taking the square root of 36 because the denominator is 2 and that's our root. The square root of 36, well, 6 times 6 is 36, so the square root of 36 is 6. C and D are a little bit more complicated. C has 2 negative exponents. So my first step, I'm actually going to do I'll do it right here. My first step is I'm going to use negative exponent rules to rewrite this with positive exponents. So if it has a negative exponent, we flip it to the bottom and make it positive. But what if the negative exponent's already on the bottom of the fraction? Well, the answer's actually not that difficult. We flip it to the top and make it a positive. So this becomes 16 to the exponent 3 over 4 over 49 to the exponent 3 over 2. And now we can use our roots. We're going to take the 4th root of 16, raise it to the exponent 3. 4th root 16, I'm going to put the whole thing in brackets, raise it to the exponent 3, divided by the square root of 49 to the exponent 3. Since we're evaluating, we should think about which we're going to do first when we evaluate. Are we going to take our root first, or are we going to raise it to the exponent? Well, if you can take the root first, because it works out really nicely, you should take the root first. How come? Because we're going to do most of this without our calculators. And if we raise 16 to the exponent 3, we get a fairly large number that would be quite challenging to take the 4th root of. But the 4th root of 16 is something that we can do a little bit easier. We've actually already done it. The 4th root of 16 is 2. So we have 2 to the exponent 3. It's much easier to raise 2 to the exponent 3 than it is 16 to the exponent 3 without a calculator. The square root of 49 is 7. So we got 7 to the exponent 3. And one last step, 2 to the exponent 3 is 8. 7 to the exponent 3 is kind of the edge of what I might expect you to do without your calculator. 7 squared would be fine, because that would be 49, but 49 times 7 requires a little bit of work to get at. You could do it, you could write it out and work it out. I know it's 343. So we've got our answer there, 8 over 343. Let's try D. D, we're going to use some exponent rules first to simplify. Our top has a 1/4 exponent. I'm going to leave it as a 1/4 exponent. I'm not going to write it as a root because we can't take the fourth root of 3 and get an answer. So hopefully we can work this out with exponents. Multiplying exponents, or powers with the same base, we would do what with the exponents? Well, we would add the exponents. Adding a half to 3/4. I'm going to change this half to 2/4 because 2/4 is equivalent to 1/2, and that's easier to add to 3/4. We should get 3 to the exponent 5/4. And our next step, what would we do? Well, we could use the fourth root, but again, we can't take the fourth root of 3, so we're not going to do that. We're going to work with the exponents. Since we're dividing, the exponent rules would say subtract. The bigger fraction, or the bigger number as an exponent is on the bottom. 5/4 is bigger than 1/4. So if we subtract bottom up and put our answer on the bottom, hopefully this works out. 5/4 subtract 1/4 would leave me with 4/4. And 4/4 is just 1. So this is 1/3 to the exponent 1, which is just 1/3, which is a nice answer, 1/3. So usually switching to roots is advantageous, but if you switch to roots and you can't actually square root, and you have terms that have a common base, you should use your exponent rules to simplify and then evaluate. 3. So we got some more fractional exponents. Let's see if we can evaluate here. We've got negative 27 to the exponent 1/3. Well, that'd be the third root of negative 27. So what number times itself 3 times gives us negative 27? Well, since it's a negative base and we have an odd root, we can get an answer. The answer is going to be negative. And 2 times 2 times 2 is 8. And 3 times 3 times 3 is 9 times 3 is 27. So it is in fact negative 3 is our answer. How is B different? Well, in B, the base is not negative 27. Negative 27 is the base here because it's all in brackets. In this one, the base is 27. So I'm going to rewrite this. The base is 27. So when we take the third root, we're actually taking the third root of 27. And the negative is still in front. The third root of 27 is 3. Negative 1 times 3 is negative 3. So in fact, we do end up with the same answer, but they are different. Well, the original is different. The answer is the same. C. We've got negative 8 as our base. We're going to take the third root of negative 8 and raise it to the exponent 5. But wait a second, our exponent's negative. So we're going to use our negative exponent rule first. 1 over negative 8 to the exponent 5/3. That gets rid of our negative exponent. You can't take a negative root of a number. You can raise a number to a negative exponent. That would flip it. But it's easier to deal with the negative exponents right away. Now we can take the third root. And raise our answer to the exponent 5. Well, the third root of negative 8 would be negative 2. And we'd have to raise that to the exponent 5 still. Negative 2 to the exponent 5. Well, 5 times 5, or sorry, 2 times 2 is 4, times 2 is 8, times 2 is 16. One more 2 gives us 32. Our base was negative. 5 negatives multiplied would give us a negative answer, negative 32. So I'm going to rewrite that as negative 1/32. Okay. If you have an odd exponent and the base is negative, the answer will be negative as well. And D. D looks weird because the base is negative 1. Let's just work this out using our exponent rules and our rationals. Let's see what we got here. Negative exponent first, so we're going to flip it. Oops, should have written that as a positive exponent because I flipped it. Let's correct that. There we go. and that means the fifth root of -1, all to the exponent 8. Well, the fifth root of -1 would be -1, because -1 times itself 5 times is -1. Raised to the exponent 8, that's an even number, so that'd be 8 -1s all multiplied. Our answer would be positive, because the exponent is even. If you have an even number of negative numbers multiplying, your answer will be positive. 1 over 1 is 1. So this is the same as 1. All right, that's it for example 3. Let's flip the page. Now we're going to do a couple of these. I'm going to leave you with B and D to do on your own, and then we're going to do a couple of the 5 examples as well. Evaluate using the laws of exponents and express your answers in radical form. So exponent laws first. Let's look at our first example. In our first example, we have a common base. And we have a negative exponent, but since we're dividing, I'm going to do the subtraction first and see what we end up with. Division of powers with the same base, we would subtract the exponent. So this would be 4 to the exponent -1/2, subtract 2. Now 2 as a fraction over 2 would be 4 over 2. -1/2, subtract 4 over 2 would be -5 over 2. And now we have 1 power. It's got a negative exponent, so I'm going to flip that to the bottom. And I'm going to use my fractional exponent to rewrite this as a radical. 1 over, base becomes the root, square root of 4 to the exponent 5. Back up here. Square root of 4 is 2, so this becomes 2 to the exponent 5. 2 to the exponent 5 is 32, 1 over 32. Okay, I'll get you to try B on your own. You can pause the video and try it, or you can wait for me to do example C, pause the video, and then you're going to try B and D together. Let's do this one. So we've got a third root of a square root of 4096. That number's a little big to do in your head, so this wouldn't be one I'd ask you to do without your calculator, but let's work this out anyways. Third root means a fractional exponent of 1/3. And a square root means a fractional exponent of 1/2. So this is kind of the same thing as 4096 to the exponent 1/2. That's the square root. All to the exponent of 1/3. And when you write it with fractional exponents, it kind of shows you what you might do. And what you might do is, well, when you have a power of a power, or an exponent raised to another exponent, you would multiply the exponents. 1/2 times 1/3 is 1/6. And 1/6 as a radical would be the 6th root of 4096. So what happens when you have a third root of a square root? Well, you multiply the roots, get 6, and it becomes the 6th root. But you wouldn't have known to do that if you hadn't switched it to fractional exponents first. So you don't need to switch it to fractional exponents now if you recognize that, well, the third root and the second root, when you have a root of a root, you'd multiply the roots and get your bigger root, which is 6th root. Now the 6th root of 4096, I happen to know offhand, is 4. But again, that would be one that you could use your calculator for. D. Well, D is the one you're going to do on your own. Similar concept to C. Try B as well. We're going to move on to example 5. All right, this is some fun stuff. This is the thing that we've been building to for 2 lessons now. Now we're going to be able to rewrite all of these as a single power with a positive exponent. Now, we talked about in the last lesson what that means. If you have multiple variables, you're going to have 2 powers, but if they're going to be multiplying or dividing, we'll count that as a single power. So in the case of C, we've got x's and y's, so your answer might have x's and y's in it. All the other ones, A just has the letter K, B just has x's, and D just has x's, so we're going to actually get a single power in those ones. We're going to do 2 together. We're going to do A and C, and I'm going to get you to try B and D. A. Well, A, we have the 6th root of 4096. k to the exponent 24, and the fifth root of 32,768, k to the exponent 15. Well, what do we do here? Well, when you have a term that has both a coefficient and a variable with an exponent, you take the sixth root of both. So what's that mean? Well, the sixth root of 4096 is 4. And the sixth root of k to the exponent 24 is, well, I'm going to show you. It's actually not that complicated. Remember, the root is the denominator of the fraction, and the exponent is the numerator? Well, that just means k's numerator is 24, and the denominator is 6. So really, the root, it divides the exponent. 24 divided by 6 is 4. I'm going to show that in my next line. In our denominator here, the fifth root of 32,768 is, of course, 8. And the fifth root of k to the exponent 15 would be k to the exponent 15 over 5, because it's the fifth root. 4 divided by 8 is something we can simplify. It becomes 1 over 2. And 24 divided by 6 is 4. 2's on the bottom, 1 over 2. I'll write the 1 just so you can see it. And then 15 divided by 5 is 3, so we got k to the exponent 3. And one last step, k4 divided by k3. Subtract the exponents, we get k on top and 2 on the bottom. Here we go. Not too bad. Let's try C. C is the one with x's and y's. A couple of things we can do first, and the nice thing about C is you can kind of tackle it from any angle you want. You can simplify everything in the brackets first, and then apply the exponent on the outside. But in this case, the exponent on the outside is -1, which means we're going to flip this entire fraction, which we could do right away, because remember, a negative exponent means take the reciprocal of the base. Well, this whole thing is the base, so we're going to flip it. We would only change the sign of the exponent on the outside, not the signs of the exponents on the inside. What it might be easier to do, though, is to do some simplifying inside first. So let's try that. We've got a -1 outside this bracket. So what I'm going to do is I'm going to apply the exponent of a product rule, and I'm going to multiply or distribute that -1 to both those terms. So that'll give me x to the exponent -3, y to the exponent -1. And that's going to be multiplied by x4, y3 over, again, we have an exponent outside a bracket. I'm going to distribute. We get x to the exponent -4, y to the exponent 6, because negative times negative is a positive. And that whole thing is to the exponent -1. I'm going to do a little bit more simplifying inside. Multiply these two brackets means add the exponents on the x's and add the exponents on the y's. So on the top, -3 and 4, if we multiply, we'd add the exponents. We end up with x to the exponent 1. And if we do the same with the y's, we get y to the exponent 2. This is starting to simplify quite nicely. On the bottom, we still have x to the exponent -4, y to the exponent 6. Still got a -1 exponent outside. We can keep going inside. Subtract the exponents on x, subtract the exponents on y. The bigger exponent on x is on the top, so I'm going to subtract top down. 1 subtract -4 is 5. So we got x to the exponent 5. The bigger exponent on y is on the bottom, so I'm going to subtract bottom up. 6 minus 2 is 4. -1 still on the outside. Last step, when we have a negative exponent to a base that's a fraction, we flip the fraction. y4 over x5. We don't change the sign of anything on the inside. The only sign that changes is the one on the outside. And there we have a final answer in terms of y's and x's. All right, that's it for lesson 4.3. Thanks for watching. Try examples B and D before class tomorrow, and we'll do one similar as a warm-up. Again, thanks for watching, and I'll see you next time.